This is 5-2 of algebra. So a direct variation is a relationship that can be represented by the function in the form y equals kx. So in this form, k is standing for a number. K is our constant of variation. So y equals 2x. That's a direct variation. Or y equals 1/3 x. That's a direct variation. One that's not a direct variation would be something like y equals 3x plus 1. Y equals 1/3 x minus 2. We can't have this extra stuff here. We can't have the adding and subtracting. We only want the number with the x. Okay, so we have an equation down here that we need to check if it's a direct variation. So I need to try to get it into the form y equals kx. So I'm going to try to get y alone. So it's 4x plus 5y equals 0. So I'll subtract 4x from both sides. I get that 5y is equal to negative 4x. Divide both sides by 5, and I get y equals negative 4/5 x. So yes, this is a direct variation. And my constant of variation, my k, is negative 4/5. Okay, so now we're asked to write the direct variation equation. So remember, it's y equals kx. So in our got it problem here, they give us two values. They give us our y value and our x value. So what we're going to do is we're going to plug that in to the y equals kx. So 10 equals k times negative 2. And I want to solve for that k. So I'll divide both sides by negative 2. I get negative 5 is equal to k. So k is negative 5. So to get my equation, I'm just going to plug it back into my y equals kx. So I've got y equals negative 5x. And that's my equation. And then they want to know what the value of y is when x is equal to negative 15. So y equals negative 5 times negative 15. A negative times a negative is a positive, so this is a positive 75. Graphing and direct variation, I'm actually not going to do this problem. I think we're okay with graphing. So when you get the equation that you should graph, just choose some numbers you want to plug in. One thing that's really important, though, is that direct variations always go through 0, 0. Right? If I have the equation y equals 3x, and I plug in 0, 3 times 0, well, that's just 0. If I have the equation y equals 1/4 x, when I plug in 0, 1/4 times 0, y equals 0. Every time I plug in 0 to any direct variation, I always get 0 out. So every direct variation graph is going to go through the origin. It's going to go through 0, 0 down here. You should remember this from our last section. If the k is bigger than 0, so if k is positive, it is a positive slope and it's going this direction. If k is less than 0, so it's a negative k, it's a negative slope and it's going that direction. Okay, finally, writing a direct variation from a table. So this time we're being asked, does y vary directly with x? Meaning, is this a direct variation? So to figure out if this is a direct variation, I've got my table down here. I need to figure out my k for each point. So I'm going to do it 3 times to figure out my k's. And if it's all the same k's, if my k is the same number, then it is a direct variation. So I'll start with my first one. Remember, our equation is y equals kx. So I'll plug in 2.25 for y and negative 3 for x. Divide both sides by negative 3. And k equals negative 0.75. So for this first one, k equals negative 0.75. And then I'll do the next one. So I'm going to plug in negative 0.75 for y and 1 for k. Well, 1 times k is just k. So again, I get k equals negative 0.75. So far, so good, right? It looks like it might be a direct variation. I just got to check one more point. So I'll plug in -3 for y and 4 for x, and solve for k. So I divide both sides by 4, and again I get k equals -0.75. So I got the same thing for my k each time, so that means yes, this is a direct variation. And then my equation, I just need to plug in my k that I got. So y equals -0.75 k. That would be my equation. Oh, not k, x. Sorry. Plug in -0.75 for k. There we go. Y equals -0.75x. And there's your homework.